Hello, and welcome to today's webinar, Supercharge the Velocity of Your .NET Business Rules with Corticon 6. My name is James Goodfellow, and I'll be your host today. When I'm not hosting top-notch webinars, I'm handling the product marketing activities for Corticon and Data Direct for Progress. Joining me today to lend his technical experience and expertise is Jim Arsenal. Jim is the Director of Software Engineering for Corticon and is responsible for shaping the product's technical direction. Also joining us today is Savarsi Mandel, Principal Software Engineer at Corticon here at Progress. Savarsi, Jim, thanks for joining us today.
Thanks, James. We're really happy to be here.
Thank you, Jim.
So before we get too far along, I want to mention that this is the second in a two-part series discussing some of the highlights of Corticon 6. If you missed our last webinar a few weeks ago on connecting to REST data in Corticon, you can find it archived on our website. All right, now back to the topic at hand. I want to start with a little bit of background on Progress. Progress is a recognized leader in application development and deployment technologies. In our 30-year plus history, Progress has consistently delivered the platform tools that organizations need to develop and deploy mission-critical applications. Now here you'll see an overview of the breadth and depth of products and solutions that we offer as a company, as well as how our products are integrated to offer adapted user experiences. We enable you to build customer scale and omni-channel applications by helping you provide an adaptive experience with applications or experiences that support all digital touchpoints needed by your users. This includes responsive web experiences, native mobile applications, and chatbots. We're also researching support for future user channels and technologies like micro apps. So switching over to the business rules world, there are many reasons why companies embrace a unified approach to managing their core business rules. But really, they boil down to some of the same core reasons why businesses do anything: to minimize risk, to lower costs, to increase revenues, and also to build and maintain trust. In this instance, we're talking about minimizing the risks of fines and penalties for noncompliance. Heavily regulated industries like healthcare and financial services face ever-increasing scrutiny from government agencies. Improving efficiencies to lower operational costs and increase profits. To maximize efficient operations, businesses are turning to automation of their cumbersome business processes. From business process management or robotic process automation, enterprises of all sizes are trying to find ways to streamline their operations by automating their rules. And finally, building and maintaining customer, employee, and shareholder trust. Consumer protection laws around data privacy are forcing organizations across all industries to protect the customer data that they collect. With the implementation of a digital decisioning solution, businesses are able to realize multiple benefits that affect these high-level business drivers. Among these benefits, businesses are able to rapidly respond to updates and changes, consistently and accurately enforce policies, and leverage predictive data-driven decisioning. For example, depending on your industry, you can now more accurately and quickly determine what discount should apply to this purchase. Is the applicant qualified for the loan? What are the recommended treatment options? And is this transaction fraudulent? When it comes to domain expertise, Corticon has a rich history of solving industry-specific business pains. Here are just a few examples of where we've been successful because we're able to help these companies parlay policy and compliance into demonstrated value. Insurance companies, expectations and habits are changing. The industry is consolidating and competition is adapting. Making decisions represents the bulk of the day-to-day tasks and core business processes like policy underwriting and claims processing. In financial services, as much as 70% of critical business tasks involve data-driven decisions. That means thousands of repetitive decisions each day for everything from loan and credit application approval to verifying customer identity to configuring new products. Governments and agencies care about serving the needs of the public while dealing with complex and ever-shifting policies and regulations, all while protecting their programs from risk and fraud, oftentimes in the face of static or even shrinking budgets. Healthcare applications contain tons of complex rules based on regulations, new studies, protocols, and demographics, with more piling on every day. When those business rules are hard-coded into your apps, changing, testing, and deploying just one rule can cost a software developer multiple productivity hours, if not days or weeks. Lastly, the world of e-commerce and retail is an intensely competitive landscape renowned for its razor-thin profit margins. Businesses in this market need to extract every possible edge to get ahead and stay ahead. When you get into the Corticon application, the first thing you're going to notice is the Excel-like interface. We realize that the folks in your business who are most familiar with rules and policies are not likely to be coders. Trying to push rules out through code can lead to a lot of translation errors. More so, Corticon is ready to go out of the box for business analysts and technical users alike. Corticon enables single-click deployment, so you won't require hours of IT implementation and integration just to get started. In addition to simplicity, the ability to create rules in one place and then push them out across multiple applications is paramount. Maintaining rules via code is time-intensive. Maintaining rules via code across multiple applications, multiple data sources, multiple languages and architectures is downright risky. There is a very real and significant threat to ensuring that rules are being applied uniformly across the disparate systems with so many variables in play. One of the major leaps we've made with Corticon 6 is how we work with .NET architectures. Corticon has historically worked with .NET, but the user experience has not always been the most effective. For this new version, however, we've overhauled our bridging technology to make the experience between Java and .NET a lot more efficient and a lot more effective. Specifically, by partnering with a leader in .NET and Java bridging, we have been able to vastly improve overall .NET performance. In fact, we've created an architecture that is 3 times as fast as previous versions. The new bridging process, in addition, is considerably easier to use and manage. And finally, this new architecture support eliminates all need for cross-compiling, thus leading to a much faster, much easier overall performance. And at this point, I want to turn it over to Jim so that he can talk a little bit more about some of the technical details of our .NET architecture changes.
Thanks, James. Yeah, what I'd like to now share with you is an overview of the new Corticon.NET architecture. As James said, this is built on a new bridging technology. You're working with a third-party vendor, an industry leader in this space, to bridge between Corticon, which is a Java-based application, and .NET. At the highest level, the way the bridging technology works is through shared memory. So when you have a .NET application, whether it's an IIS application that has Corticon deployed to it, calling to a Corticon decision service, or it's a in-process application, both of them, the architecture is effectively the same. You'll have a DLL inside of the .NET application that's calling off to Corticon through shared memory. It does it through shared memory because it's very fast, very efficient way to integrate. It provides the communication. It's actually bidirectional. When you call Corticon from .NET, you'll be passing your payload data, the JSON or XML that you're passing to Corticon to perform some decision service on, and then the updated data will be turned to the .NET application through shared memory as well. What's really nice about this is that the .NET code, it runs in the Windows Common Language Runtime. The Java code is running inside of a JVM. As James said, we're no longer dealing with the cross-compilation headaches. It makes deployment much easier and has lots of other benefits as well. The Corticon provides the DLLs. This isn't something that you need to create. We provide the DLLs to make it easy to go from your .NET application to call to Corticon. The process isn't all that dissimilar if you're using IIS from how it was in prior releases. For an in-process applications, a bit of changes, but it actually is a simpler process today. As James noted, the 6.0.NET performance is a lot faster than it was prior. The chart that I'm showing you here has a few interesting aspects to it. If you look at the different bars here, there's a set for XML, a set for JSON, and a set for business objects. Within each of those sets, there's a 5.7 Java. That's sort of the baseline that we want to compare against the Java version. There is the .NET is the blue as it was in 5.7, and then there's yellow, which is the 6.0.NET. So let's start first by just looking at the set of bars over the XML on the left. The red is Java, blue is the old .NET, and the yellow is the 6.NET. What you'll notice here is that the 5.7.NET was much, much slower. There was a big performance penalty that you paid using .NET with 5.7 and earlier of Corticon compared to the Java version. Java was much faster. If you compare it to the 6.0, the yellow to the red here on the left, the .NET performance is really on par with the Java performance. And this is a big, this is a significant advancement here. If you're deploying .NET, whether it's in process or in an IS application, you'll get much higher throughput and much better performance from your system. Another thing that's really of interest here is if you look at the set of bars in the middle, the JSON, you'll notice all of these bars are smaller than the XML bars. One of the things that we really encourage customers is, ever since we introduced the REST support back in 5.6, you now have the ability to pass JSON to Corticon. And JSON, in all cases, is faster than XML. This just has to do with the nature of what it takes to process XML versus JSON. But if you look to the right at the business objects, you'll see that the JSON is actually faster than the business objects as well. Again, the tall bars here are bad. The shorter the bar, the better. If you have a performance critical application, we really encourage you to adopt JSON and pass the JSON into Corticon. And really, if you have the ability to do JSON, it's highly recommended. So why did Corticon need to change? We had a very successful .NET implementation for Corticon, or through the use of cross-compiling. What the old approach allowed you to do is you could take your Corticon decision services, their generated Java code. That's how Corticon operates, and then you could cross-compile them to .NET, deploy them in process or to IS. But as James noted earlier, there are shortcomings to that. It's not as efficient or as fast as we want. So the big thing we gained was performance. That was evident in the charts that I showed. The 3x performance improvement. That's just within our own testing. We've had cases that have been higher, and we certainly hope that you'll experience even greater performance gains with 6.0.NET. So that was the big one. We get much faster performance. Other benefits we get is the old approach with the cross-compilation, it was very complicated. It was hard for users to adopt, to integrate with their CI/CD, continuous integration, continuous deployment practices. It's basically there was more ways that you could make mistakes and get something wrong because of the level of complication. With 6.0, you don't have to do any of that. It's much easier to add, to integrate a decision service with 6.0 with your .NET application. Another issue that we had with the old approach was diagnosing problems. With the cross-compilation approach, it made it very difficult to diagnose a problem. If something went wrong, if we got a stack trace from the .NET side, after the code was cross-compiled, it was very difficult to map that to the Java side, which made it harder to resolve problems as fast as we would like if you encountered an issue. With the new architecture, the Java code is running in the JVM. .NET is running in the Microsoft runtime. We just bridge between them. They're each running in their own native environment. It makes it much easier to support and manage them. And we are building a new architecture on industry-leading Java.NET technology. So we found a partner who has a lot of experience bridging between Java and .NET applications. They've been in this business for 10 plus years, and working with them, we were able to come up with a solution that works really, really well for Corticon. And the old approach that we had, using IKVM, it's kind of run its course. It's at the point it's become more or less an orphan technology. We still support it, but there's no development being done on it, so it's not going to support new versions of Windows. So if you, especially looking down the road, new versions of Windows will come out. We may not be able to support the IKVM approach there, and you would have to certainly update to 6.0. Hopefully, by the time that happens, everybody's already made that migration. So what does this mean if you're a .NET user today? Well, as I said, I keep coming back to the no cross-compilation. If you are using .NET with Corticon, you know very well what I'm talking about and some of the headaches that can be involved with it. So you will not have to do that step anymore. If you're deploying Corticon in process, there's a few things that you'll need to change in your .NET project. You'll have to include the Corticon DLLs. So these are the DLLs that effectively make it possible to cross the bridge so you can go from the .NET code to Corticon. And there's a few properties that you'll need to set in your project. Very simple steps to do, and in a few moments of Archie is going to give you a live demo of this, just showing you how easy this is. And once you're done, your existing projects will work with 6.0. If you're deploying with IS, it's actually easier because the process isn't all that different than it was prior. You will need to deploy Corticon into IS. We provide the scripts to do that. There are some property settings that you'll need to make. But otherwise, if an application is calling Corticon in IS as a REST or a SOAP service, it's unaware. The REST and SOAP interfaces haven't changed. It's the same API. So there's no changes required to the applications which are consuming the decision services. There are some prerequisites with 6.0 when you're using .NET. You must have the VC 10 and 11 redistributables installed. A lot of times you'll have them installed already as part of another application, but they are optional window packages, and if you want to use Corticon Server.NET, you will need to have them installed. So deploying Corticon.NET in process, here's sort of the simple steps that you need to follow. This is what Savasri will show in just a bit. You have to find Corticon work in your .NET project. So this tells Corticon where it can write the log files, where other runtime files will need to go. You'll need to provide pointers to the DLLs, so the DLLs that come with Corticon to cross the bridge. You'll need to have that information in your project as well. And you'll have to edit your app config to find location of the Corticon class files themselves. So they're pretty simple changes. We provide sample projects that have the settings, so you can, for the most part, just cut and paste them into your existing projects. If you're deploying to IS, the steps are similar as they were in prior releases. We provide a script that will install the Corticon web application into IS. You will have to take a few steps as you did prior to give Corticon access to where to write the sandbox, the log files, the runtime stuff that gets written during execution. We provide an app config that will define the properties for Corticon for the REST and SOAP services, and any other changes that you made in terms of securing endpoints and stuff, you would make those as you did prior. Now, if you do have .NET Business Objects, for those who are not familiar, Business Objects are a technology that's available in Corticon where you can create a business object or sort of an object representation of the entities and attributes that are inside of your vocabulary. We support this both with Java and up until 6.0, we did support this with .NET as well. So we don't directly support the .NET Business Objects with 6.0, but there are other alternatives you have. The reasons we don't support this is that it would require a custom DLL. If you do have a need for this, as I bring up in the last bullet point, let us know. We're really encouraging customers to go the JSON route because the main reason that people would have picked business objects in the past is for the performance advantage it would give them. When they're doing Corticon in process, people are typically doing that because of performance reasons. They want to get the lowest latency, the fastest throughput. If that's what's driving your decisions, then we do encourage you to use the JSON because you'll get even higher performance. So if you're using business objects, the first avenue to explore is to use JSON. If you do have a hard need for some reason for the .NET business objects, give us a call. We'll talk to you about this and go through the options that you have in a little more detail. So at this point, I'm going to pass it off to Savasri. She's going to give you a demo of both Corticon .NET being used in process and deployed to IS.
Thanks, Jim. And let's see how we can run the .NET in process. As Jim mentioned earlier, we do ship a .NET Visual Studio 2017 solution along with our .NET installer. You can find the sample located at Corticon Work Samples Clients in Process, and this is the Visual Studio sample which we have. It's a very simple in-process sample. This just demonstrates how we can use Corticon Server in process. This loads a decision service and invokes a decision service on a JSON payload. As you can see, the first thing which we need to do is set our Corticon worker. That's one of the very important settings which we need to do to enable .NET in process. The next thing it does is add a decision service. All the assets it needs is shipped along with the installer, so it should just run out of the box. So we set the settings for the Corticon worker. We then add the decision service. For the sample, we are using a process order, which is shipped, and then we execute that using a JSON payload. So let's just run the sample. So somebody can just pick this up, debug it, step through the code, and then create a sample similar to this. Okay, initiates the CC server, which checks if the decision service is already deployed. If not, then it'll go and deploy the decision service, and then we execute using the JSON payload. As you can see, the decision service was executed, and this is the output from Corticon Server. Let's look at the app config. As Jim mentioned earlier, there are certain things which we need to enable .NET to run and process. The important thing is you need to have the .NET Server license with you, and that should be copied to its appropriate location. In this app config, you can see that the .NET license is actually getting picked up from Corticon Home Server. The other jars and DLLs are also mentioned here: CC config, CC bundles, and the CC third-party jars. All of these are shipped and found in the Corticon Home. The next thing is to see how we can run Corticon Server on IIS. So to run Corticon Server on IIS, we do have it. It's the same process. We have the install.bat, which you can run, which basically deploys the access on IIS. And this creates and deploys it, creates a directory for IIS and puts it in inetpub. The settings to enable .NET on IIS are pretty much the same thing. We do have to enable the permissions. One of them is edit the permissions and add everyone. So this basically allows the access to create the CC server sandbox and the logs. To enable REST and SOAP on IIS, we need to turn on certain features. One of them being that enabling the .NET framework for IIS, and also have the IIS settings. The common HTTP features and needs to be enabled. So we need to have the HTTP redirection and the HTTP errors. All of those things need to be enabled. And once we have that, the IIS should be all set to run our .NET server using REST and SOAP APIs. I've already deployed it. So let's just restart the server. And let's see if our IIS is actually working. So to actually test that the IIS is set up and is ready, we can hit one of our REST APIs, which is the server ping. This just tells us that the server REST API is enabled. We can also use the web console to actually add the server, the localhost .NET server, and manage the server from there. So as you can see, I already have my .NET server here, and it's up and enabled, and we can actually manage the decision services. We can see how many decision services are deployed. For now, I don't have any decision services, but the metrics is collected for the server. The other important thing to have the .NET server for working on IIS is also to remember that if you need a valid CC server license, which needs to be placed in the inetpub, access, lib. So we need to get our valid license and replace it here. So that's how easy it is to actually deploy a Corticon server on IIS and in process. And now I'd like to hand it over to James for Q&A.
All right. Thank you, Savarsi, and thank you, Jim. That was really helpful. At this time, we do have a few questions that I want to pose to the panel. All right. So, Jim, I'll pose this first one to you. The question is .NET Core supported?
So, Jim, .NET Core is not currently supported, but that will be coming in short order. It's primarily an update to some of the third-party technology that we use. But, yeah, that is in the works.
Okay. So I currently deployed to IIS as a REST service. Are there any changes necessary to my clients, which call Corticon Decision Services?
No, that's one of the nice things with the change. Even though it's what we've done with .NET and 6.0 is a pretty big architectural change. For the clients that are consuming the decision services, via REST or SOAP, there's really no visible change to them. So if you're deploying to IIS and it's a REST service, and you have a client, a workflow or other tool that's calling the decision service, there should be no changes to that.
Okay. I got a question about the yellow bar for business objects in Corticon 6. Is that something that has disappeared or is no longer there?
So business objects are still available for Java, but they're not available for .NET. One of the things that in the slide that we did talk about was that with .NET, the method by which you could, if you needed business objects, we would have to create custom DLLs for calling it, basically DLLs that could proxy the objects that you have. So, if a customer has a need, a hard need for the .NET business objects that wants to update to 6.0, well, then they'll have to give us a call. Either talk to their account manager, talk to support, and we can arrange a discussion on it. That said, our recommendation is that customers go the path of passing JSON, even if you're in process. The advantage of business objects, or the reason people adopted it historically, was for performance. But the performance of the JSON is just superior. So if that's really your driving force, you're better off going down the JSON route.
Good, great. Are there restrictions? So speaking of JSON, are there restrictions in the JSON or XML that are passed to .NET or from .NET to Corticon?
Yeah, so there are no restrictions that we're aware of. At least anything beyond that would be what you could pass to Corticon in general. So if there's a JSON payload that you need to pass, that you could pass to Corticon Server, the Java version running inside of a Java app server, you'd be able to pass that same JSON to a Corticon Server .NET running inside of IIS.
How long do we expect that the IKVM approach to .NET is going to be supported in Corticon 5.7?
So it will be supported following the Corticon Progress product lifecycle. So 5.7 is supported until 2022, I believe. I think it's early 2022. So we will continue to support it up to that point. But between now and then, we're not going to add support for new platforms. So if a new version of Windows comes out where the IKVM solution is no longer workable, we're not going to provide support for that. The support for platforms will be limited to what it is now. If if a new version of Windows came out and you wanted to deploy Corticon to it, then you potentially would have to update to 6.0.
Good. Do you have any information around precise timing for in-process versus out-process timing?
So if I understand the question here, it's what's the performance characteristics of running Corticon in process versus running it as a web service. So if you're running it as a web service, you have the extra step. Obviously, there's the extra hop. Making it over to the web service, going through the web tier to get to the Corticon server to actually execute. If I'll have to go back into the slide deck here. For the performance information, we do know that for Corticon, the actual rule execution time is relatively short. You're talking in the order of milliseconds. The overhead, it comes into, or so not the overhead, the bulk of the time goes into just packaging the payload up and moving the payload data back and forth. So if you have this is the reason why JSON is so much faster than XML, because XML you get the whole DOM involved, and it's just a much more extensive way to process data. Whereas with the JSON, it's just much lighter weight, and that's why it's faster. So I'm just referencing the chart here locally, and the XML versus the JSON. The testing that we did in here, this was all done in process. And the numbers of the JSON relative to XML and is evident within that chart. The overhead, if you're deploying as a web service, it's just going to be what the cost of going through your web tier. And some of that's going to be dependent on the app server they're using, whether you're using WebSphere or JBoss or IIS. It's really just the only sort of Corticon portion within there is it's just the data has to get passed down to the REST wrapper, which would be effectively doing what you'd be doing in process. So it's sort of a long-winded answer here, but the rule execution performance will be the same. The JSON processing would be the same. It's just that from the web tier above, is where the cost comes in, and that's really dependent on your deployment architecture. In most cases, it's still high performance. There's a low transaction time. You're talking, in the order of milliseconds for a response. But again, that can vary based on your architecture and what you have in place.
Okay. And as a follow-on to that question, can you talk a little bit about bulk operations in this framework? And the context is, the question says that many of their complex services require wake-up calls, and is this new framework resolve the issue of the first-time call taking more time?
I've been thinking about this. The wake-up time issue for Corticon was primarily if you were deploying assets which needed to be compiled. So if you deployed, say, an ERF file and the Corticon server, the first time it was called, using server-side compilation, would have to build the EDS file for it. That was a potentially very expensive wake-up time because it's building the whole decision service. Now, that was never recommended as best practice. It's always recommended that you deploy the compiled assets, just because if there's a problem during the compilation, you don't want that showing up in your deployed environment. You want that showing up, in testing, and you are deploying something that's been fully tested. In the case of .NET, the problem was further complicated because of the cross-compilation that would occur. Those issues go away because there is no cross-compilation. There is potentially a cost of, a sort of warm-up cost in loading the DLL if it hadn't been hit prior, but it should be nothing, in comparison to the sort of issues that people have reported in the past, where they were both building their assets and doing the cross-compilation in the deployed environment. Basically the first time the decision service was called.
Got it. So stepping back just for a moment, what are the advantages to deploying Corticon.net in process versus, say, like a web service?
So it really depends on what your objectives are from architecture perspective. The main reason people or customers have chosen to deploy in process historically has been for performance. When you have a sort of really critical low latency where the difference between a 10 millisecond and a 5 millisecond response is really important. That's when they would opt to do a sort of an in-process deployment. You might see that in like an e-commerce solution where you are it's absolutely critical, the response time to the customer or the user that's accessing the application through some other tier. It doesn't mean that the web service deployment is slow. The web service deployment is REST calls are very, very fast, but it's not going to be as fast as in process because you don't have the hop. And that's really, when somebody's really trying to squeeze out milliseconds, that's when they'll start to look at in process. There can be other architectural reasons too. Just somebody, if they're building out a system where they have no need for an application server. This is just a sort of bespoke application that's running. Well, you can do in process there as well. This is one of the really nice things about Corticon from a deployment perspective, is that we have a lot of flexibility. You can deploy it to Java or .NET, and in both of those you could deploy it to an application server. You can deploy in process. So you have lots of options for how you want to deploy.
All right, great. That's going to wrap it up for the questions today. For everyone taking the time to join us today, I appreciate it, and we'll speak with you soon. Thank you.
Thanks, everyone.
Thank you.